belongs in the section with the average value of a function. Average value of a function was more important, right? Absolute value, other than the fact that they start with a, don't necessarily have anything to do with each other, right? I want you to realize that if we're trying to evaluate an integral that involves an absolute value, the way you need to do that depends on whether you're doing it graphically or algebraically. If you're looking at it graphically, all you have to do is think about what does this function look like, absolute value of x minus 1. In grade 12, you learn what that looks like. What does it look like? What does the function x minus 1 look like? Yeah. No, I don't know why I didn't give you more of an axis here, but so it looks like that's what x minus 1 looks like, but if you want it to be absolute value of x minus 1, this goes up like this, right? So if you want the, that was a really good job of tracing over the other line. Okay, so that's what that one looks like. If you want to do the integral of absolute value, how is it related to integral of just the function without the absolute value? The integral from 0 to 3, here's 0, here's 3 over here somewhere, right? Let's think about what this area is, because that would be 2, right? Because it's 1 down. So this triangle is going to be, I mean, you could do this without even doing any actual, finding an antiderivative. You can just do it by knowing the area, right? This is 2 times 2 divided by 2, right? What's the area of that triangle? 2. What's the area of this little triangle in here? This is 1, 1. So it's going to be a half, right? That's going to be a half, the area in there. Right? Half of 1 times 1. So if you're trying to find the integral of just, I don't know if I asked it down below, but the integral from 0 to 3 of just x minus 1 would be negative a half plus 2, right? Or 1.5. I guess we could be grown up and call it 3 halves. If you have the absolute value in there, graphically it makes sense what happens, right? Like you do that. And now what's the area, right? Before the area was all of this was negative and all of this was positive, right? And some of it canceled out. But if you do absolute value now, you have all of this which is positive. But you also have, and I lost the, I don't know, I can't get the graph back now. Terrible. It's very disappointing. So you have this, right? All those areas that were, just like the graph flipping up here and becoming positive y values, the area flips up above and becomes positive, right? So instead of, that being negative and that being positive, they're both going to be positive, right? It's going to be positive 1/2, right, for that little triangle, and 2 for the big triangle, right? Plus those two together, this could be 2.5. If you want to do it algebraically, like if you want to do it completely algebraically without looking at the graph, you need to find this point. You need to know that point, okay? You need to split it into 2 intervals, right? Split it into intervals using the zeros, or in other words, x-intercepts. Okay, split it into 2 intervals. So instead of 0 to 3, okay, you're going to go, so integral from 0 to 3 of absolute value, we'll just write that again. But we're going to say this is equal to the integral from 0 to 1 of the reflection of that, right? What's the reflection of that function? How do I give the equation of this part of the line? If I'm writing this absolute value as a piecewise function, what's that part of it called? Negative x plus 1, right? It's this function, but changing all the signs of everything, right? You make it negative x plus 1 instead of x minus 1, right? piecewise function, that part of it is negative x plus 1, this part of it's x positive x minus 1, right? So you have to break it apart into the two pieces, right? The piece that's reflected, right, so negative x plus 1, plus then we got to do the integral of from 1 to 3 of x minus 1, right, dx. Forgot the dx over here. Or instead of doing this, right, instead of doing that, what could I have done instead? Instead of putting the negative sign in the function here, what could I have done? Yeah, just put it. You could have just put it in out front of the whole thing, right? You could have just said, whatever this is, it's negative, right? Either way, whichever way you do it, right? That's an or there. If you do it algebraic, you'll find either way, right? Whichever way you do it, you'll find that, you use an antiderivative. Antiderivative of x minus 1, what is that? 1/2 x squared minus x from 1 to 3, right? And the other part of it here is just going to be the same thing. So either 1/2 x squared minus x from 0 to 1 with a negative sign in front, or without the negative sign in front and just changing the signs of that. If you find this easier, okay, to just keep the negative sign in front, that's fine. If you go through and do this, you're going to find that the values add up to what you expect, right? If you sub negative 1 into the first thing, what do you get? You get negative, I'm kind of out of room here, but sub 1 and 0 into the first thing, you get negative 1/2. And you sub 3 and 1 into the second thing, it'll all work out to what you expect it to work out to, right? This is going to be 9/2 minus 3 minus 1/2 minus 1. If you work all that out, you're going to get what you expect here. 9/2 minus, let's make it all the same and practice our grade 8 stuff, plus 2/2. Hopefully it adds up to the right thing. 9 has 3/2, 2/2, 4/2. 4/2, what do you know? What is that the same as? 2. Negative 1/2 plus 2. 1.5. Okay, so whether you do it algebraically or graphically, you're going to have to think of it as intervals like that, right? If you went to do it in, like using the calculator thing, the calculator feature, if you went to use that numerical integration, which on those calculators that we use is called int8, if you did this on the calculator, you could just put in absolute value of x minus 1, comma, x is the variable, right, on your calculator, from 0 to 3. You could just put it in as is, right, on the calculator, and it'll give you the right thing. Or if you're using the Ca12, it actually shows it the way it's supposed to. 0 to 3, absolute value, x minus 1, dx. And it'll give you the right thing, okay? Using the numerical integration thing on the calculator, I can leave that up to you to do, right? See how quick we can do. Maybe, okay, we'll do this really quick here. Okay, remember under here, math all the way down to numerical integration, fnint, except I don't want it there, I want it in the home screen. 8, 9, close. Absolute values under math, over to num for number operations, ABS, anti-lock braking system. You got what? Did you really? Oh, for absolute value. Yeah, what did I do down here? Did I add it up wrong? Oh, because I'm stupid. That's why. Because I am stupid. Because this is minus 1/2. I'm sorry about that. Because this is the absolute value. I was thinking of what the answer was up here. Yes, this is supposed to be 2.5, isn't it? Because I'm stupid when I subbed it in here. When you put 1 in here, You put, this is what happens, you try and do things in your head without writing it down. 1/2 minus 1 is minus a half. That's why. So you're right. It is supposed to be 2.5, right? That's what we had before. So this is why we can confirm things on the calculator to check if our other stuff's right. So this should give you 2.5, right? Thinks about it for a while. Remember, we don't trust this past about 4 or 5 decimal places because it's just approximating things, right? It's not doing calculus. It's just finding areas of rectangles and adding them up, right, or whatever. So don't put that number down with 12 decimal places. Are we okay with this? 10 minutes or less? The other question this is actually just random picture here. Work it out one way or the other. You can do that question right now pretty quickly, I think. The scale doesn't necessarily match this. It's not drawn to scale because that's 1 and that's 3 and it looks like the same distance. So I wouldn't judge it based on how the areas look. But then you're able to do assignment 11 and you're already able to do assignment 10. Basically, the month of May is going to be finishing assignments while doing that last unit too. And doing those last 2 tests, right? We have the double block today. I do want to talk about the last section in here after lunch. But then the second half of each class, like the second half or 2/3 right now, and then the second half of after lunch you can use to work on some assignments. Okay? This is not a huge concept, this absolute value thing. The next section requires more thinking. It's more abstract and stuff, but I think we'll be okay with it.